For basically all of human history, science has been, well, a human thing. It's been about our curiosity, our ingenuity. But what if that's about to fundamentally change? Today, we are looking at something pretty radical, a new frontier, where AI is shifting from just being a tool for scientists to actually becoming the scientist. I mean, just think about that for a second. What if an AI could win a Nobel Prize? It sounds like something straight out of a movie, right? But this isn't just some fun thought experiment. It's the real, ultimate goal that researchers in a brand new field are shooting for. A future where an AI could, all on its own, come up with an idea, test it, and prove a discovery so important it literally changes the world. And this whole idea, this future, it has a name: Agentic Science. That's the big concept we're going to unpack. It's all about this massive shift, moving AI from being a super fancy calculator to being a genuine colleague, an autonomous agent that can run the whole scientific method from start to finish with very little help from us. So how in the world did we get here? This idea of an AI scientist didn't just pop up out of nowhere. No, it has an origin story. It's been an evolution, from a simple helper to a potential pioneer of discovery. It really breaks down into 4 levels. At level 1, we had the AI as an oracle. Think of something like AlphaFold, a kind of magic calculator that could solve one huge specific problem. Then we got to level 2, the assistant, where AI started automating bits and pieces of research, kind of like a lab tech. But here's where it gets really cool. We are just now stepping into level 3, the autonomous partner, where the AI can handle the entire discovery process. And the future? That's level 4, the architect, an AI that doesn't just make discoveries, it invents totally new ways to even do science. And that's the key takeaway here. Level 3 is not science fiction. It's not a someday thing. It is happening right now. This is the absolute cutting edge, where these AI agents are starting to act like independent researchers. And that is exactly what we're going to get into. Okay, so to really get how this is even possible, we need to pop the hood and look inside. Let's do a little dissection of the mind of an AI scientist and look at the 5 core abilities that give it the power to think, act, and, discover. So what's the secret sauce? What are the fundamental building blocks that make this all work? Well, it really comes down to 5 capabilities that all work together, letting an AI act less like a piece of code and more like a human research team. First step, it needs a brain. That's planning and reasoning, so it can make a strategy. Then it needs hands, which is its ability to use tools. Everything from Google to actual robots. It also needs a notebook, its memory, so it can learn from its mistakes. It needs a team, which means collaborating with other AIs. And finally, it has to get smarter over time. That's evolution, the ability to improve itself. Everything really kicks off with planning. This is the engine, the cognitive core of the agent. It's the part that can take a massive, ambitious goal, like discover a new material, and break it down into a logical, step-by-step plan. Without this, an AI is just a big library of facts. With it, it's a strategist. But hey, a great plan is useless if you can't actually do anything. And that's where tool use comes in. This is what lets the AI reach outside of its own digital brain to run code, search scientific papers, or even control robots in a lab. And this is where the other abilities really come alive. Memory works like its lab notebook, making sure it never makes the same mistake twice. Collaboration lets it call on other specialized AIs for help, kind of like a chemist calling a physicist. And evolution, well, that allows the whole system to get better and smarter over time. It's this complete package that really makes it a scientific partner. All right, so we've gone through the theory, the whole anatomy of an AI scientist. Now for the really fun part. Let's look at how these agents are already out there in the wild, making real, actual discoveries in labs as we speak. And let's be super clear. This isn't just happening in a simulation somewhere. These AI agents are producing tangible results in big fields like chemistry and materials science, discoveries that are being tested and proven in the real, physical world. And this table just shows the incredible impact. Check out Cost Scientist. It designed and then ran a complex chemical reaction by itself using real lab equipment. Or look at Robin, an agent that sifted through tons of data and came up with a hypothesis for a new use for an old drug. But then there's MothGen, which did something mind-blowing. It discovered and helped create 5 brand new materials. Seriously, let that sink in. This AI didn't just find something that was already hiding in the data. It dreamed up hundreds of thousands of new possibilities, and out of all of that, it guided scientists to physically create 5 of them. These are materials that did not exist on Earth until an AI imagined them. Now, as unbelievable as all this is, we aren't exactly living in a world of robot Nobel winners, at least not yet. Agentic science is facing some pretty deep challenges that we have to figure out before these systems can become truly reliable partners. And these are the four big ones. Reproducibility. It's the foundation of all science, right? But how do you reproduce the creative thought process of an AI? How do we validate that what it found is actually new and not just a hallucination or a clever mashup of what it's already seen? Can we trust its answers if it's a black box that can't explain why it thinks what it thinks? And of course, the huge one, who is responsible if an agent discovers something dangerous? Let's just zoom in on reproducibility for a sec. In human science, we write down our methods, like a recipe, so someone else can follow it and get the same results. Simple enough. But for agentic science, that's not going to cut it. We need to record the agent's entire journey. Every decision it made, every dead end it hit, every single piece of data it looked at. It's a totally new, much higher standard for what a lab notebook even is. And all of this brings us right back to where we started, to the ultimate test for this entire field. Researchers have a great name for it, the Nobel Turing test. The question is simple, but the implications are massive. Can an autonomous agent, all by itself, generate a discovery that is truly worthy of a Nobel Prize? Because passing that test would mean we've witnessed the most profound shift of all. It would mean AI has finally evolved from just being a user of scientific tools to being a creator of scientific insight. It's that moment the apprentice doesn't just master the tools, but starts inventing their own. And that leaves us with one last, absolutely fascinating question to think about. If an AI agent actually passes that test, if it makes a discovery that rewrites our textbooks, who or what steps up to accept the award? The answer to that is going to define the entire future of discovery.